Hello and welcome back. And today we are going to understand about the log transformations. When we use the log transformations, how we use the log transformations that we are going to understand today. So before we understand the log transformations, let us understand a very simple example, right? But before even taking that simple example, let me explain you why we use log transformation. In previous videos, you could have understood that transformations we are doing just to make the data uniform. We are making the data uniform for two purposes. One thing is that none of the important details should be left behind. First thing. Second thing is that the data should be scaled in such a manner that it should not create any kind of bias, right? Because machine learning models are not like us, we have to train it mathematically. So we need to take care of this thing, that how the machine will understand and how we can improve our data, how we can do the data engineering on our data so that the data doesn't have any kind of bias introduced or any kind of relevant details could not have been missed. So these two things we must need to take care of. So that is why we use different kind of transformation techniques. And one of the transformation techniques is the log transformation. Let me give you a simple example. Suppose there are two cities C1 and C2, and there is one more C3. In cities C1, C2, and C3, we want to see the data related to the sales we have done for our product. Okay. Suppose in city C1, we have done the sale of our product as $1 million. So this is $1 million. And in city 2, we have done only $100 sale. Okay. In city 3, we have done only $1,000 sale. Okay. Suppose this is our data. Okay. This is our data that we pass it to the machine learning model so that it can learn some pattern. Suppose you are drawing this data on a graph and you are drawing the sales on, uh, you know, x-axis, on the y-axis, right? And the cities you are taking on the x-axis. Then for $1 million, it could have a bigger dollar bar here. We are creating a bar chart, for example. So there is a bigger bar here for $1 million. And for $100, it could be something like very small. You can see very, very small. And for the 1,000, you could have this thing. Similarly, there could be other cities. C4, C5, and C4. Suppose you have done somewhere around, $2 million sale. Okay. And in C3, we could have done $1.5 million sale, something like that. Okay. Or you can say like $3 million. You can take anything. So these will create bigger, kind of bars here. The data related to city C4, C5, they could create bigger bars. If your model will see these bigger bars and also some smaller bars, then in that case, your mathematical model, which is basically a machine learning model, it may understand that this data is really not relevant or really not important. And it can drop this data. It could drop this data, which will be wrong. In which condition it may be wrong? You might also be thinking that yes, this may not be useful, but never assume anything. You are teaching a machine, right? So before you take any decision that this data may or may not be useful, just think in this manner. Suppose in C2 and C3, it could be that the population is very small, very small. Suppose in this city C2 only 3 or 4 families are, they are living, right? Just consider a hypothetical situation. Don't go into the practicality that how is it possible that in a city only 3 or 4 families will live. Just consider it as an example as of now. Similarly, for C3, it may be that there also the population is very less. Maybe 30 to 40 families are there in the entire city. And if you see a trend that in city C2 and C3 as well, there are 79% of the people and 89% of the people, or 80% of the people who have purchased your product, right? And in city C1 as well, it could be that people have purchased only 75%. And in case of C4, even you have done $2 million sale, it could be that there are only 72% of the people have bought that. Do you think that if you are analyzing this trend, do you think that this data C2 and C3 is not important? It is important. You can very well understand that this is also important. Then what you will do, what you have to do now. So, okay. So in this case, what you have to do, you need a magnifying glass, kind of magnifying glass, which makes the higher values or bigger values, which shows the bigger values as smaller and smaller values as bigger. You need a magical kind of glass. You can just understand, you can just assume that you have got a magnifying glass. When you are putting that magnifying glass onto this bar chart, then whatever are the bars which are bigger, they become smaller, and whatever bars are smaller, they become a bit bigger, right? So in this case, what will happen? There will be uniformity across the data, and this data related to the this one here, which is looking very small, this was also important. So now when you will be when you are going to do this kind of scaling, this kind of magnification, you cannot literally say it as a magnification. You have a magical magnification glass, basically, which just makes bigger things smaller and smaller things bigger, right? So this kind of magnifying glass is known as logarithms in the mathematics, right? So I hope you must have understood what is log in mathematics. You could have understood it in your college days, school days, but yeah, this simple definition, this practical definition, why we use the log, you could have seen it for the first time here, right? So this is really important to understand why we use the logs. What is the purpose of using the log? Okay. So, yeah, in case of log, what we do, suppose I'm just giving an example. Suppose we were talking about the $1 million sale. Okay. So in case of $1 million sale, when you will take the log of this value base 10 on the base 10, then in that case, log will come as 6. And when you are talking about $1,000, in that case, on a scale of base 10, on the base 10, you are taking the log. You need to take the log on a base. What is base? That we are going to understand very soon. So on the base 10, we are taking on the base 10. We have taken 1 million on the base 10. So we are taking 1000 as well on base 10. So if we are taking 1000 on base 10, then the value will come as 3. Just count the number of zeros, 1, 2, 3. Okay, here just count the number of zeros, 1, 2, 3, 4, 5, 6. Okay, so if you see here now, this will be 3 and this will be 6, right? But the difference is not too bigger. Difference is not bigger. Difference is not that significant that your model should understand that yes, this data is really not important for me. So with the help of the magnifying glass, which is known as the logarithms, we have now become able to increase the size of the bar which was smaller, and now we are able to decrease the size of that bar which was bigger. So in practical terms, in a layman terms, if some layman asks you that what is the log, then in that case you can say that log or logarithms are just a magical magnifying glass which makes the bigger values smaller and the smaller values bigger. And when we use it, the example was in front of you. When the smaller data is also importance because of the scenario or something similar scenario that we have discussed in this example, right? So I hope you must have enjoyed this video. In the next video, we are going to see some basics of the logarithms, and then we will understand that how we do the logarithmic transformation using the Python code. Till then, have a nice day and bye bye. Thank you.